Immediate family.
Hi everybody, thanks for coming out today. If you're still getting food, that's fine. And we'll have a lot more food probably left over if you want to come by after the talk and get some. So I'm Dave Love. I'm an assistant scientist at the Johns Hopkins Center for a Livable Future. Thanks so much for coming out to our second lecture in this lecture series, Food and Health, What's Fish Farming Got to Do with It? I'm going to give you, tell you two little bits of information before we get started, plug some of our work at the center, and then I'll hand it over to Jillian. So the first thing I want to, well, I guess three things. So within our lecture series this fall, we've got one more event coming up in November. It'll be a film screening of Farming the Seas, and we'll have a panel discussion afterwards after the talk. So we feel like November is a good time to kind of kick back. Maybe you're busy in classes, you're tired, you just want to watch a movie for 50 minutes in the middle of the day. So it should be a good movie, really interesting. So while you're here, really pay attention to this slide. If you're So the CLF puts on, we have a grant that we do every year. This is the second time we've had this RFA. It's the Aquaculture, Public Health, and Environment Research Grant. It's open to Johns Hopkins faculty, doctoral students, postdocs, staff, to do work on aquaculture and the environment. And we'll be releasing the RFA in a couple months. So look out for it. It should be a good way to stimulate more work around aquaculture at the university. Another thing, if you're a doctoral student, we have a doctoral student fellowship. It's called the Center for a Livable Future Lerner Fellowship. And I see a couple people in the audience who actually who are fellows. You want to raise your hand if you're in it? Okay, great turnout. So if you want to apply to be a fellow, we've got the call for applications comes out in early 2014, so consider checking it out on our website. So that's all. I want to pass it over to Jillian Fry, who's the project director for the Public Health and Sustainable Aquaculture Project.
Thanks, Libby. Thank you all for coming. We're really excited to have Libby Fetherston here from Ocean Conservancy. She came in from Florida yesterday. Libby is the deputy director for the fish conservation program at the organization, and they work on advancing options for effective science-based management of the fish resources, as well as options for better, more efficient data collection and monitoring. She has a degree in biology and also environmental management. And one problem that they've worked on is advancement of offshore aquaculture, addressing the issues that come up with the advancement of that without the proper policies in place to deal with those issues. And Libby is also heavily involved in Gulf restoration from the BP Deepwater Horizon oil disaster, and she works to align businesses, academia, government agencies, and citizens in support of ensuring ecological restoration is science-based and integrated across political boundaries and fully funded, and also inclusive of offshore Gulf waters where much of the damage remains unknown, instead of projects on land that are interesting to citizens but not relevant to where the funding is coming from. So, Libby?
Oh, I've got it.
You're all set then.
It was a smooth handoff. Good afternoon, everybody. I'm Libby, and I'm very excited to be here to talk with you folks. Ocean Conservancy has been working in fisheries conservation nationally and in the Gulf of Mexico for 15 plus years. The issue of open ocean aquaculture is one that caught our attention 2006, 2007. There was a lot of momentum around national legislation, and I was a part of the development of that program and some of the implementation of its fine work. But I was not a part of the aquaculture department. I was part of the fish conservation program, which is a division that most human beings wouldn't make, right? Because fish is fish and your seafood counter, and only an environmental nonprofit could think fish that you catch and fish that you grow are two totally different programs. But alas, we managed to do this. So fundamentally the question is, why do we care about this? Why do we care about open ocean aquaculture? And And really, this is a story about unintended consequences. And to illustrate that for you, I'm going to take you to this beautiful island here of Kiribati. This island is off the coast of Australia, and good fishery conservation types were really concerned about the depletion of fisheries resources in and around the islands of Kiribati, and what that would do to the local economy and the fisher folk that depend on that resource. And so conservation groups, 2009, got together and said, if we give Kiribati Islanders a more economically profitable alternative, then they won't have to fish and they won't deplete their resources, and they'll have economic and ecological security. Great goals. So they set about producing a coconut oil business model in Kiribati. And so the Kiribati Islanders have transitioned from this resource extraction to this sort of value-added coconut oil product. And the results of this for the local environment was that the local fish populations decreased by 17%. So how and why did this happen? Well, as it turns out, the people of Kiribati wanted to work less and have more leisure, and the coconut oil production capacity allowed them to do that. They made more money and they had to work less. And what did they want to do with their free time? They wanted to go recreationally fish. So the laws of unintended consequences are pretty mysterious unless you know a whole lot about the environment that you're working in. So getting back to the point, so the Earth fundamentally is a water planet, and it supports a lot of things that are really important. Food security is one. Controlling temperature and climate is, I think, a sort of MVP type thing that the ocean and the planet does that's really underappreciated. And the things that we do with things like fisheries have unintended consequences for even things like temperature control and climate. But sort of getting at the heart of aquaculture, so the things that we want, the benefits of fish, omega-3s, great brain development in babies. I've got a young son, and we were feeding that kid salmon, and wild-caught salmon from a very young age. And things that, the people from the School of Public Health work on every day, and things like, reducing obesity, getting nutrients into people. But, we want the benefits of fish, but we can't keep doing things like this. This is a fish market in Japan, and I don't know how many of you know or care a whole lot about bluefin tuna, but that's sort of one of the tragedies of the open ocean is the sort of hunting of the last bluefin tuna. One of these fish can go for $750,000, and that's a pretty strong incentive to go catch the last one, if you ask me. So we're trying to get the benefits of fish, but in order to do that, we're depleting wild resources at a rate that's a little bit alarming, particularly for big, high-value species like bluefin tuna. And so just to sort of illustrate that, so here's where fish were in 1900, contrast with where fish were 99 years later. And the depletion of sort of table fish, or the stuff, people in Kansas like to eat, has been pretty staggering. So in thinking about aquaculture, the diversity of aquaculture is amazing. 336 species is pretty profound. And if you look down the second from the bottom, marine fishes, which are of course near and dear to my heart, that's what I work on, is a really small percentage of that. Yet they generate more value than their percent in quantity, and so there's a business opportunity there that people like salmon farmers are capitalizing on. But if you look at where this is going on, North America is really a pretty small percent, 1.2% of the actual overall production. Of course, these figures are quite old. I'd be stunned if it were a whole lot different now. But all that is to say is that there's a real opportunity for finfish aquaculture in the US, where that's the kind of stuff we like to eat, and so that's the kind of stuff we are more likely to grow. And so here's some sort of likely candidates. You can see amberjack, cobia, Atlantic salmon, threadfin, halibut. These things are already sort of in production. How do we make more stuff that people like to buy at restaurants is the question that US marine aquaculture is asking. And this is the kind of tool that we're going to use. So you can see the diver who's there for scale. These net pens are massive. They're massive and they're submerged. They're anchored to the ocean bottom. And so in places like the Gulf of Mexico, we get real concerned about what hurricanes might do to something like this. But so this is this is an actual open ocean aquaculture facility. I think this is the one in the Bahamas that's growing cobia inside of it. Now, how you get in there with a vacuum and get those cobia out is a little bit beyond my area of expertise. I'll let you guys sort of think through that technical conundrum. So here's just a brief wrap of what we know so far. So one, population here on this planet is increasing, and it's increasing at a pretty shocking rate. Two, malnutrition and protein deficiency is a massive problem on this planet. So if you look at the red and the orange areas, at least 20% of the population in those areas is undernourished. So 1 in 5 human beings doesn't have enough nourishment. And so that's pretty alarming. So another thing we know is that the global production of wild capture fisheries has leveled off since about 1980, and aquaculture is filling that gap. But in order to do so with things like marine fish, we're talking about all kinds of impacts that nobody really understands, that nobody's really regulating. And so we've got some concerns here, like what goes in, what comes out, but we'll have a chance to talk more about this. So in sort of summarizing what we know about aquaculture, about a hungry planet, it seems like you have two choices, right? Full-scale industrial fish farming to feed a hungry planet, like this is an actual sea in China, and those are all buoys, and that is all aquaculture. The entire thing is covered in aquaculture. So your option is to do this, or to do nothing, right? Because the slide we briefly looked at with impacts about what goes in terms of chemicals and antibiotics, and what comes out in terms of concentrated waste, they're real challenges for ocean environment. So this is like your classic good versus evil, right? You either do this and you feed people, and you sort of screw over the environment, or you don't. And these are your options if you're a good environmental conservation group like ours. Or is it? Or is that your only choice? So the shark here asks a very good question. So what about the role of public policy and law in sort of helping us find some middle ground in these areas? So we've got a number of reports and documents, the one on the bottom coming from the Government Accountability Office. That sounds very official. I would read that and I would heed it if I were a managing entity. But all of these documents are calling for an overarching national guidance or national plan before we expand open ocean aquaculture, because doing it in the absence of a regulatory framework is a terrible idea. I don't know if you guys remember what happened when we deregulated banks and say let them buy mortgage-backed securities and whatnot, but like I'm learning a cautionary lesson from this, and unregulated business to me seems like a shaky proposition. So this is what all of these sort of blue ribbon panels recommended. And the benefits to a national approach are many. You have one single regulatory framework. The people that monitor clean water can talk to the people who monitor fish sustainability and health. And you can have this whole interconnected network of people who are ensuring that the wild fisheries in areas associated with aquaculture are protected. You can level the playing field for industry. People who are trying to farm fish in California have a very different regulatory structure than those in the Gulf of Mexico. In the spirit of full disclosure, that last bullet is probably the least of my concerns. So another idea, another picture of why this national approach is really valuable is another one of those sort of unintended consequences and cautionary tales. So in Chile, they were farming salmon at a startling rate, right, accelerating production to, I'm sure, great benefit to at least 6 or 7 people in Chile, potentially not the communities that were then devastated when they had this enormous outbreak of disease that killed off a number of those salmon. And that was just a startling, what can go wrong if you don't have a set of environmental standards to regulate the outside of business. So in the absence of any framework, national framework of laws and policies, the federal government said, you know what, we've got a law that regulates wild capture fishing. Let's just shoehorn aquaculture into that and let these 8 regional fishery management bodies do the hard work of permitting open ocean aquaculture however they see fit. And so the little icon next to the NOAA icon, that's the Gulf of Mexico Fishery Management Council. That's what you see on their t-shirts if they're running around, their polo shirts. And so they picked up this ball and said, okay, we are going to go ahead and we're going to set a system of permitting open ocean aquaculture for Gulf of Mexico waters because NOAA said we can. And at the end of the day, the fisheries law is an imperfect vehicle, and it's probably illegal because nowhere in the act regulating fishing activity does it say, oh, and hey, go ahead and regulate aquaculture if you feel like it, right? It is not permitted by this law. And I have, I don't know, probably like a 45-page comment letter on the sort of nasty specifics of where I think the law falls short of allowing this that I can share with anyone. But I think these sort of two sentences sum it up. It's imperfect and it's probably illegal. So the other side of that coin is the California state model, which sets forth 17 rigorous environmental and liability standards. And this is an impressive collection of ways to put the precautionary principle into action, right? They're great standards, but no one has yet, since that went into effect in 2006, no one has applied for a permit in the state of California to open an aquaculture facility because the standards are prohibitively high. They have sort of strong liability standards, strong environmental standards, and so the question is there a way to sort of meet in the middle here with this sort of put a pen in and do with it what you like? That's the way we do things in the Gulf of Mexico. I don't know if you guys heard about it. Or in California, where they have really strict standards for what you can do, and it's prohibiting people from moving forward. So the options, it seems, are if you want to find some middle ground here, is that you use the law that you have, which is imperfect, the Magnuson Act, or you get a new law that allows you to do this activity. And so, you guys live really close to DC. What do you think the odds are of passing a protectionist bill regulating development of a brand new industry? I had the same reaction. So we have to sort of use the law we have, right? It's weighted toward that direction. And that's challenging because NOAA's interpretation of the utility of that law is very different from mine, is very different from, say, an aquaculture industry representative. And looking at the way the California standards line up, which is this sort of very small type on the left, and how the Gulf Council's permitting system stacked up with those on the right, the Gulf Council managed to get 3 out of 17. Which, I don't know how many of you take tests and have to pass them, but that's a big fat F, even in the Gulf of Mexico. And the things they managed to get right were requiring non-native and non-native species, prohibiting use of GMO, genetically modified species. And then this was really tough. They ended up saying they would only issue 10-year permits, right, as opposed to 200-year permits or something, which is how we do things for oil and gas leases. So 3 out of 17 in the Gulf. Maybe the California standards are a little strict, but this is sort of an embarrassing track record here. So the interesting thing, and I know you've all been asking, this is all great, Libby, but how does this relate to hockey? The interesting thing about rules is illustrated by this. So I don't know how much you all know about hockey. In hockey, fighting is like a sort of a serious offense, right? If you have too many men on the ice, it's a 2-minute penalty out of 20 minutes in that period. If you're fighting, it's a 4-minute penalty. So almost a quarter of the playable time, you're sitting in the penalty box. And the folks who regulate hockey, the NHL, they were really concerned about concussions in sort of big, burly men who are punching each other in the head. And so they had a new rule this year. If you take off your helmet to fight, because real men fight without helmets, you'll get an extra 2 minutes. So we're talking 6. We're talking more than a quarter of the entire playable period you're going to be in the penalty box if you take your helmet off. So these two enterprising gentlemen, the second game of the season, are squaring off to fight. It's New Jersey versus New York, bad blood, bad news, and the one guy says, and I kid you not, I can get you the news article, I'm gonna whomp you, Barch, but I don't want to take my helmet off and get that extra 2 minutes. And so you know what Barch says? You take my helmet off, and I'll take your helmet off, and then we won't get the 2-minute penalty, because the penalty is only if you take your own helmet off. So the funny thing about rules is there's almost always a way around it, right? And so this is, I think, a particularly awesome example of exactly the lengths people will go to get around the regulations. So thinking about regulating open ocean aquaculture, how do we define what is responsible? So we've got this backdrop of this sea in China that, just as far as the eye can see, you've got buoys for aquaculture. I don't know if there's a shipping lane in here somewhere. I don't know what other uses you could have in this area. That seems like it's probably not responsible. So the net pen on the bottom that we talked about earlier, like is that responsible aquaculture? What are the standards we need to apply here that protect the marine environment, that protect the food supply, but also allow businesses to produce protein for a hungry planet? And who should be defining this, right? Because if I define it, we end up with the California bill. If industry defines it, we end up with the Gulf of Mexico regulations. And I think there's probably some middle ground here to be attained. And so I don't know if any of you have had the pleasure of seeing Jeremy Jackson speak. He's a very dynamic guy, and he's not an aquaculture guy, right? He's a marine ecologist, and he's done some really interesting research. Hopefully it didn't lead to the Kiribati coconut oil debacle. And he's talking about the most important scientific challenge, and that's not for oceans, that's not for fisheries, that's period. The most important scientific challenge is how to make aquaculture sustainable. And that's pretty telling, because Jeremy Jackson, he's kind of a big deal. So is he talking about something like this? So this is just like a schematic of how you can layer different types of marine aquaculture together to mitigate the impact. So you've got a bunch of fish in a pen, and you put traps below, and you have things that eat, tragically, fish effluent, and they absorb that, right? Like, I'm not gonna take that lobster to my next party, but I mean, at a minimum, it's not going back into the benthos. And then you have these suspension filter feeders that are filtering sort of different waste that comes through, and then seaweeds growing. And so, I mean, this is sort of a clever idea of how you think of sort of like what are the biggest problems in aquaculture, and how can we use natural systems to try to mitigate those, as opposed to putting a bunch of drugs in the water, or just saying, hey, the currents are going to take all that poop wherever, and it'll be fine. I think that's a little naive. So, yes, sir?
Can you say what's happening in the top left, those two icons?
Oh, that's just sort of the feed going in needs to be from a sustainable source, and no drugs should go in. So that's just sort of a nod to the other couple of major issues. So this is a very interesting book. And I think this quote really talks to the previous slide of how do we start thinking about eating fish that work better for us, as opposed to taking something like a salmon, which is a predatory fish that needs to eat protein to grow. Why are we taking 2 pounds of sardines from off the coast of Chile, grinding it up and feeding it to a bunch of salmon in British Columbia to get 1 pound of marketable salmon? I mean, that conversion ratio, I am certainly no statistician, but I don't like that math, right? We are wasting protein somewhere in here that could be usable. So Paul Greenberg is asking the question, how do we start thinking about fish that work better for us? And one really good example would be tilapia, right? Those are frequently substituted for more expensive fish without our knowledge in places like the Gulf of Mexico, illegally by restaurants. But it's so substitutable that somebody can pay for a $14 red snapper sandwich and get a $2 tilapia fillet in there and not know the difference, right? But tilapia are vegetarians, and they can be raised onshore in recirculating systems, which I think your own people here have demonstrated. So that's what Paul Greenberg's talking about. How do we value the fish who do more for us, as opposed to telling the consumer, hey, you want salmon, buy more salmon, when the stuff that goes into bringing that aquaculture salmon to market is nonsensical, the kinds of drugs that go in and the feed to output ratio. So back to this slide. In thinking about the role of public health and excuse me, and finding a middle ground between the industry sort of develop at all costs and the environmental don't eat or pollute my ocean, sort of where's the middle ground between these factions that are getting a little bit more polarized? It's hard to sort of hear anything the industry has to say with a straight face. I think they probably would say the same thing of me, but they're not here to defend themselves, so it's not my problem. How do we talk about this in a way that's meaningful, right? How do we talk about food production and preventing bad things from happening in a way that's meaningful? And I think there's an enormous role for public health in that. And everything you see on this chart has some other idea or concept that we can explore and think about. What are the best practices? What are best practices for offshore aquaculture? What do they have to include? They have to include fish meal that comes from a source that's not toxic, right? So like, what are the right inputs into this system to make sure these fish get a healthy diet, because they're going on to feed people. And because I come from fish conservation, I'm going to add a little plug for, and that should be a sustainable source. If you're unsustainably fishing one thing to feed it to something else, to feed to somebody, to save wild fisheries, you've done a terrible job of figuring out how to save wild fisheries. You've just saved a wild fishery that you care more about than the one you're depleting in the first place. And then sort of drugs and chemicals, I think we've got some real issues here. The kinds of stuff you need to put in a net pen and make sure that disease doesn't replicate in those closed environments. I think there's some best practices about density numbers out there in terms of what kind of diseases and parasites are coming out and effluent. Like what are the total maximum daily loads that can come out of a pen of cobia in order for the surrounding environment to still be able to produce food that people can eat? And where do you need to site these in order for fish waste that goes into the benthic environment to not end up in our food supply? And I care about things like, okay, what about the predators that are attracted to this? What happens to them in this equation? Escaped fish, what does that do to the wild population? Are those things, if they're genetically modified, are they going to outcompete whoever lived there first? So there are heady questions involved in this, but there's a real potential here to describe the best case scenario for how we can farm fish and feed people. What are those fish? If it's not salmon, if that's not a great idea, what are the right fish we should be farming in open ocean aquaculture, where the feed that goes in is sustainable, the stuff you have to put in there to keep them alive isn't so bad? These are questions that public health can help us answer. So, I mean, fundamentally, you guys ask these questions every day, but you ask them about chickens, and you ask them about hogs, and maybe you ask them about French fries, and I thank you for all of that. But this idea that we started off with, that there's this emerging opportunity for aquaculture, particularly in North America, where we are a small part of the market share, particularly in marine fish, where there's value in selling that in the marketplace. This is sort of the next wave of food production, and fish is really healthy for you. People keep telling me that on my television and the little flyers that come home from school with my son. And so it's sort of the next frontier for us, but there's no framework to tell us how we should do it. And based on, I mean, the fact that Congress isn't even working, I mean, the government's not even working, so no one's really going to develop this framework for us. So I challenge you to think about what that framework should and ought to be. And so from my perspective, the vision for the future of fish has to include aquaculture, right? Like wild capture fisheries leveled off in the 80s. I work every day on the sustainability of US marine fisheries, and we just exported our model to Europe. The European Union looked over and said, like, oh, the way they do that fisheries management is actually pretty impressive, and they've adopted that catch-setting framework because we're doing a pretty good job, which is great. So how do we keep that track record of success and apply it to things like open ocean aquaculture? How do we develop the right frame for this for other people to adopt? And the environmental community hasn't gotten there, and the industry hasn't gotten there, and so I think we need a new messenger. And I think we need a collaborator too, right? I think the NGO, environmental groups, and industry could come together and have some pretty productive dialogues about how we use the law we have to make sure aquaculture development is both ecologically and economically sustainable, because everybody really has to benefit from this, not just like 4 guys who invested a bunch of money in a fish farm, right? So, but at the end of the day, research that is just about describing something may not be as valuable as research that is applied to tell you that you should be afraid of something, right? And Gladys here is in a lot of trouble, but Gladys doesn't know it yet. And so to me, as just a member of the public, as a consumer of the information that the public health community puts out, I would really benefit from the work that you guys do to think about that for me, and help me understand what's right behind my shoulder that I don't even know to be worried about. So I find myself much less interesting than I find all of you, And so I want to know what you guys are interested in hearing more about, right? Like I know about fish, I know about aquaculture. So I want to hear, like, talk to me about what you guys are doing and what, if anything, you got sparked in your head by the discussion so far. And we've got tons of time for that. And then I've got one sort of last thing to bring up at the end. I will call on people, I'm not afraid. Yes, ma'am.
So we have a question. You were talking, it was really interesting to hear about the unintended consequences part of that. Can you give some examples of how a regulatory framework responds to that? You know, is it like, are there feedback, you know, you set up the framework in theory, you know, people start using that framework, but then an unintended consequence happens, right? And so is it then a feedback loop back to change the regulatory framework, or do you have examples of that, or is it sort of?
So far, we've done that badly, and sort of a buzzword in fisheries is adaptive management. And if you can build in review and refine points in your regulatory process, you get better at that. But there are a lot of unintended consequences that you can logically predict, or science can help you understand, or looking at similar ideas or concepts that have gone forward, you can sort of see what went wrong and try to buffer against that. And that's, I think, what a regulatory approach to this would try to do. But in fisheries, the most recent iteration of that, the national law that regulates capture fisheries, said, all right, if you go over your catch limit once in every 4-year period, you've got to go back and review your process. And so that kind of requirement to go back and review, you know, if X then Y, is really useful, because otherwise you could go years without going back and looking at lessons learned. And so I think some of that we're learning to build in, and, you know, blanketing it under the phrase adaptive management, which is easier to say than it is to do, of course. Yes, sir.
If one used the criteria of sustainability, what percent of aquaculture at this point would meet that criteria?
Well, how are you defining sustainability?
I'll let you define it.
Oh, that was artfully done and unfair. So I actually may let, if we have any other sort of marine aquaculture types in the room, answer that, because I really only work on open ocean finfish. And if you look at the finfish, their track record's not that bad. I mean, it's pretty expensive to put one of those pens together. And I think the amberjack facility, Kona, in Hawaii, has a decent track record of sustainability. I wouldn't use them as the model of success, but I wouldn't be afraid to eat something that they produce. But, you know, most of this is going on in international waters, where maybe they don't even have reports of what kind of drugs you put into that pen. Maybe they don't have requirements to monitor and protect water quality. And so it's a little bit hard to say in the absence of data around these facilities. Unsatisfying answer.
And I think the second question deals with how much of aquaculture is dependent upon repetition?
Is it dependent on?
Dependent upon external drugs, antibiotics, growth promoters, or whatever else is used in aquaculture.
Does anyone have a thought? Yeah, I think almost all of it.
Well,
I mean, I think you can't condense fish in an unnatural area without disease. And I think a lot of the drugs people use are preventative, because it's more cost effective to buy the drugs than it is to clean up the mess of diseased pens.
I would just maybe want to hear from Steve Rogers and Chris Tellini at the University of Maryland, who joined us and have a recirculating facility in Baltimore. Can you maybe describe the difference between the research approach versus the open ocean approach?
Well, all these ocean net pen operations must have a land-based component, because you have rootstock, that's usually done on land. You have fingerling grow out that has to be done on land before you stock your net pen. We have a prototype system that's recirculating 100%. We use no antibiotics whatsoever in our system. You got to look at it from an aquaculture point of view as well. antibiotic feeds are extremely expensive, so you want to avoid that at all costs. Even net pen operators, if they put so much nutrients in a body of water that pollutes their water, they're hurting themselves. Okay. Originally, a lot of shrimp farms and stuff did a lot of negative impact to mangroves by digging ponds and stuff. And they've gotten away from that. They've gone more to zero water exchange. Chris, want to add something to that?
Yeah, I mean, I think the use of antibiotics is exaggerated to people who don't work in research. I mean, you really, like Steve said, you don't want to use that stuff. It's not cheap. Fish feed itself isn't cheap, and then you add on the drug companies and a patented antibiotic, and it just goes up a lot. You don't want to do that. And usually it's an issue with somebody's not implementing BMPs, best management practices. They let their water quality go bad. They don't have the proper backups in terms of oxygen delivery or emergency backup systems. When the animals get stressed, they get diseases. You can pack, I mean, we have a fish system where we have, what was the last run, Steve? 75 kilograms per cubic meter?
Yeah, usually somewhere between 65 and 70, 72, 74 kilograms per cubic meter, which is very high density
And we've
system.
never had bacteria outbreaks because we maintain the water quality in good condition. Fish don't get stressed. And those secondary, opportunistic pathogens don't take hold. So as long as you keep your animals healthy, you can keep a pretty high density. And it's just a matter of designing your system correctly, making sure you have the right backup systems in place so that when something does go wrong, your fish may get stressed out for a short period of time, but not for an extended period of time where they are going to get those secondary infections. So,
This is an aquaponics facility?
No, it's a marine.
Marine.
So we're raising sea bream and European sea bass in a closed system. All of the solid effluent is captured, and we do a number of things with that. We use it as a carbon source for denitrification in the system. We can put animals in the system, grow them out from a 40-gram size to about 450 to 500 gram fish. We can do it in 9 months with zero water exchange. The water is crystal clear almost all the time. All of the solids that come out of the system, we run into a methane generator to generate methane gas. So we can capture at least 10% of the energy that goes into the system as methane gas and put that back into the system. The whole thing is to try to make it as green as possible, the smallest footprint as possible, and reduce any of the nutrients, get rid of all the usable nutrients. When you talk about waste coming out of the system, nature doesn't have waste, okay? It recycles everything. So I think in aquaculture, you've got to get to that approach. It's not a waste product, it's an unused resource. And some of the multi-trophic level images you had there, they're trying to do that. And there's places in Vietnam where they've actually done it for many, many decades, centuries ago, that they have fish aquaculture operations, they have algae production, kelp production, and also shellfish production on the bottom, all in the same body of water. I think the problem becomes is when you try to go from feeding a population to making a profit. When you start bringing in making a profit and try to employ people in an industry, they push the limits beyond where it should be.
Well, so that was the question that I was gonna pose to you: is what do you think the prospects are of taking your operation to scale? And it gets at that profitability question.
There's the larger you get, the more profit you get. That your
economies of scale.
Yes, economies of scale. That's what I was looking for. Thanks, Chris. Because you can buy feed in greater amounts. All the salt water that we use, we use artificial salt water. Fish would grow in our marine fish, but we can raise them at half-strength salinity. It works very well. Normally, a fish's internal salinity is somewhere around 18 ppt. We can raise them at 15 ppt, so it's less stressful than full salinity seawater. So, yes, we would like to see it expand, especially here in Maryland. But no, it's a huge undertaking to get a facility of that size, you're talking 5, 6, 7 million just to get in. So that's a huge undertaking. So but the ocean net pens are extremely expensive too. And the problem is, you have experiment design ones there, the globe one that you had a little image in the bottom, that aquapod. I think those are a nicer unit than aquapods, but when you take them out into the open ocean, you have to anchor them. It's extremely difficult. You're working in this marine environment. Freshwater environment, it's a lot easier to anchor that stuff down. When you're dealing with salt, things are corrosive. You got to use stainless steel. You got storm stresses that you have to handle. I know they've done some of the net pen cages that you see in the top right-hand corner in the Mediterranean. They have ones like that when storms come. And the whole thing floats with buoy, with aeration. They actually can deflate them and sink them down to the bottom and leave them there and actually not feed them until the storm has passed and then raise them back up. But sighting that stuff with, like the second image on the left-hand side, that pen is extremely close to the land. Okay, you're in very shallow water, so that would have to have a really strong current to dissipate any waste coming out the bottom of that. Otherwise, you're not going to be around very long. So you're going to pollute the environment right where all your money's sitting on the fish.
So to me, so one, like, kudos, what a spectacular thing to be working on and doing it so successfully, is how to take the sort of green best practices and get them implemented by industries who are investing these millions of dollars in open ocean net pens and may have the incentive to say, like, well, we invested all this money, if we just put 20 more fish in, we'll be able to sort of squeak some profit margins out. So what are the tools the tools we have at our disposal to reach out to policymakers, to the environmental community who clearly needs a bigger, better message, to the industry itself, to really end up at best practices, from a food systems and food supply perspective. I mean, good ideas have to go to scale, and if we're going to get them there with a sustainable framework, we're going to have really powerful messengers. And I think public health has that opportunity. But so, was anyone else sort of scribbling questions down, thoughts on the role of public health? Yes, sir.
It sort of seems like there could be a big place somewhere in there for shifting consumer attitudes, which has been done in the past from a marketing perspective of taking relatively undesirable fish, rebranding them. All of a sudden you have Chilean sea bass instead of like mud puppy or whatever it was called before that. And it's a highly saleable product now. Is there a role in that overall transformation to a more sustainable paradigm to try and shift consumers' preferences towards the fish that are more easily raised without drugs, more easily raised in sort of higher density, not the predatory fish, so that you can keep them on a vegetarian diet? If you could shift to a fish that requires fewer of those expensive inputs, maybe there's a sort of way that the industry could reimagine the whole process to not include drugs, which are such a huge cost input, by using fish that are marketable but not requiring quite as much of so many inputs to get to that marketing stage.
Yeah, I'm sure there's a whole sort of social component to this, and marketing, and then economics, certainly because the drugs are so expensive. So eliminating those is a profit issue. And I'm just thinking about in terms of marketing, like when the cholesterol information came out about eggs, like egg sales just did that, right? But that was a public health connection, right, with heart disease, and cholesterol was a big buzzword when that all happened. And so, there's probably research and information that will help us get to that point, right? Like these predatory fish are, whatever it is, like, the feed that they have is from this source, which could lead you down this path. I mean, those were really potent marketing campaigns around eggs that were really effective. And people in wild capture fisheries are trying to do that, take the sort of trash fish and rebrand them as something as more desirable than just, oh, it was the stuff we caught when we were trying to catch something you actually want to eat. And there's markets and chefs in DC and in Houston are the two that I've just read the most about, that are telling fishermen we'll pay you for whatever you catch. It's legal. You have to throw some back because they're too small or what have you. But bring in whatever you catch and we'll buy it. We'll give you a fair market price. The fisherman doesn't care. He'll sell you whatever he catches if there's a market for it. And they're turning all of those fish into something on the menu, right? So they're repackaging it as a sustainability issue and as a health issue in terms of lower down the food chain and mercury. So there's a whole sort of story that these individual chefs and markets are telling about what they're doing, and there's something compelling about that story that's bringing in public health issues like mercury, sustainability of bycatch and sort of ancillary fish populations who just happen to be swimming next to the thing you really wanted to catch, and how do we really incentivize that or give it a nudge? I think is a fantastic question.
Yeah, it's sort of partway there because you have this more health conscious, I think, consumer who really focuses on fish over other types of protein, or would choose fish over a different type of protein in their diet. I think there's a lot of people who do that for health-based reasons. You sort of got them halfway in the door already.
Yeah, there's something there. I can feel it. Yes, sir.
So just to talk about the health-based aspect of fish, from what I understood was that marine fish tend to have, one of the reasons they're so famous, obviously, is the omega-3 protein, or whatever it was. And omega-3 is, from what I understood, it actually comes most from vegetarian sources, so that the algae that they eat in the water, and that fish don't actually produce it themselves. So that if you have farm fish that don't actually eat enough of that, they won't actually give you the health benefits. So I don't know if there's enough work being done to ensure that that is exactly what the fish are giving us, if you know what I mean.
Yeah, that's an excellent link there. So what are the reasons that we are demanding fish in the first place? And is the farmed equivalent giving us that? And are we having to feed it the thing that we want to get, right? Like, are we having to give supplements to salmon to get us the omega-3s that we want in the first place? But that's a great sort of research question and that link to make to try to sort of produce some evidence for why we should maybe be doing something a little bit differently.
Yeah, I think why we should feed them more vegetarian diets in the first place, because that would take most of these predatory fish a little more off the market,
yeah,
if you will.
So you said a lot of aquaculture is used to feed the human population. Do you know if there's any percentage of the fish that are produced from this method used to feed livestock or meat production?
I'm sure some percentage does go to that, and my example is a little roundabout, so follow me if you will, and then I'll ask for some expert opinions from the room. So I worked on fishing boats in Alaska, and they require you certain, like a pollock trawler. Pollock, if you've ever eaten like a McDonald's fish witch, that's what you've eaten is pollock from the, usually the Pacific Northwest. Whatever they catch in their net, they've got to keep. They're required to use it in some way. And so all the stuff they can sell, like cod or a flounder or something like that, they'll package and they'll sell. And the stuff that they can't sell, like say the bones of cod or other sort of fish that come up, they turn all of that into fish meal, and that's all used in fertilizers actually. But they're required to keep it, so they turn it into something. And so my guess would be that from these aquaculture facilities, there's plenty of byproduct that's turned into something else, but whether there's like a directed, this is farmed to produce like feed for cattle or something like that I don't know, and so I'll see if anyone can answer that question.
Products that come out of aquaculture production are not fed to livestock, but Libby was exactly right that fish meal produced is given to livestock. About 68% of global production of fish meal goes into aquaculture feed. So the rest of that is used for other things. And some of that goes to livestock.
There might be two sort of kind of caveats. There are forms of aquaculture to raise bait fish. So that's like a small component. Another, this is more of a caveat, but it isn't really done, but has been theorized. So they're trying to develop new USDA organic aquaculture criteria. And part of that is you have to know where the fish came from that you're using as feed to raise your farm fish. So some people are proposing, well, you could use aquaculture to raise small fish and then feed them the big fish. So at least you have a chain of custody. And I think from the talk today, that's kind of a questionable use of resources that some people are talking about. So, the idea
That would be like raising tigers. You know what I mean? Like raising the food, the animals, to then feed the tigers, and then you can eat tigers. You know what I mean? Like we take wild fish and feed it to farm fish, but to actually farm fish to then feed to farm fish, that seems very crazy.
So that's not done yet.
It's not done yet, but they're trying to figure out what a farmed organic fish will.
Because there's increasing calls for, and it's one of our sort of platforms, is the fish used to sort of turn into fish feed has got to come from a certified sustainable source. And those are hard to come by in open ocean fisheries, and so if you can farm your own and certify it and then feed it, so that would be an unintended consequence, right? Like if you get a law that says your feed source has to be certified as sustainable, you're probably going to have all kinds of cockamamie ways of getting a certified feed source, like growing your own in an aquaculture facility. So
if with the premise that fish is healthy and we want people to eat fish, but if you go to the grocery store, it's a premium product. Among animal proteins, it's always the high end price. So how can we make fish more affordable to maybe compete with some other plant protein and animal protein out there? And is that even what the point should be? Should we just leave fish in the ocean alone to recover because we've been devastating them for 500, 600, 800 years? Or is there, you mentioned there's a middle ground, but what's the approach to kind of link in the health side with consumption, getting it to a price where people can actually eat it?
So some of that price reflects subsidies, right, for industrial farming of beef and chicken and sort of other things. And so, it's a little hard to say, pump subsidies into the fishery industry, because I don't think, my mom was right. 2 wrongs don't make a right. Don't tell her I said that. So, it's hard to say. So I think fish probably will always exist at a premium unless and until there's some really efficient way to industrialize the process of producing them, or to eat more of what we catch instead of discarding it, and have fish that are sort of lower in the food, sort of who eats who pyramid of the ocean, go to market, because the reason we pay so much money is because those predators that we want to eat, like snappers and swordfish and sharks, are becoming more rare, and it costs more to go get them and process them. They also deteriorate quite quickly in a seafood case, and so there's a sort of gotta get it out the door fast turnover, and there's a lot of waste in supermarkets that the supermarket has to then pay for. So there's some confounding factors that I don't know that we'll ever get to a price comparison. Chicken fillets are awfully inexpensive. So, but that's, and so that might, I think that's a compelling question to ask, but that might not be where the answer lies. And the answer may lie in something more like trying to transition away from protein sources that are more destructive to things that are more healthful for you and for the environment. Like, is that a message that's going to resonate in Texas? Probably not. So is there some compelling evidence we can put together from a health perspective to start making that case? I hope so.
And then just a follow-up to that, do you see fisheries and aquaculture following on this groundswell of the food movement, the regional and local food movement? Do you notice that in Florida or other places that you work? Could that be part of the solution?
I think it has to be. And a friend of mine, I was just at his wedding 2 weekends ago in New York City, and him and his wife just started a fish co-op. You sort of have the vegetable co-ops where you get whatever kale or, to me, completely unusable vegetables like kohlrabi, come to your door because that's what's in season, and just because I don't know how to cook it doesn't mean it's not valuable. But they started something like that for local fisheries, so whatever fishery was in season per se, or whatever the fishermen caught that day, they knew they had a market for it because they had a co-op of people who were going to learn how to cook kohlrabi with, threadfin or whatever happened to be the catch of the day. And their business model, it's a nonprofit, but it's really taken off because people in New York City are really proud. They're proud of their ocean heritage, and people in Louisiana are fiercely proud of that. And I think there's a real sort of eat local thing happening in Louisiana as well. And so that's a great option. But a lot of those fish are still really expensive, and so we're still talking about maybe not the top 1%. We're still talking about the top 45% of people being able to afford that kind of protein. And so, is that where the global impact is? It's going to be significant, but in terms of the people who need better nutrition, who need access to less expensive, healthful protein sources, it's something like keeping all your bycatch and finding a way for that to get to a market. There might be an answer in there somewhere too. That's the sort of a subcategory of eat local. Like eat local and eat local discards, or whatever. Compelling campaign there somewhere. I'm sure. Yes, sir.
Are there aquaculture regulations in the EU at the national or the EU level actually that could serve as models, or there's nothing like this there as well?
I cannot answer that question because I don't know what the framework in the EU looks like.
I have a second question. You talked about the precautionary principle, and it wasn't clear to me whether you think that it should play a major role in guiding drafting the regulations or not, because that's also a principle that antagonizes a lot of people, and it's a contested principle. So I was wondering whether, conceptually but also strategically, if it's useful to appeal to the precautionary principle or not.
So, fundamentally, I am a pragmatic person. I work for a pragmatic organization, and we haven't found the precautionary principle to get a lot of traction. And so, while it is the fundamental underpinning of like the California State Bill with those great 17 environmental and liability standards, it hasn't gotten us where we want to go, which is this national framework that allows businesses to grow fish and feed people, but make sure that happens in a way that doesn't harm wild fish, the environment, the food chain, and what have you. So the precautionary principle, I think, is really useful to set a marker, sort of what's the platinum model, sort of what the basement looks like, right? It's that Chile collapse of salmon, and to help just frame the space in between. And so I think looking at, so what would the precautionary principle tell us to do is always an important step for me in terms of policy analysis, and what are we striving for, but what in here do we think we can actually achieve in terms of like a middle ground and a negotiated outcome? Is it, at the end of the day, particularly in the sort of anti-science, anti-regulatory climate in the United States that we live in, you've got to work with the system you have, in my opinion, and so that leads you to sort of dream big, but then negotiate somewhat smaller at times.
I was wondering if you could talk a little bit about the Gulf oil spill and any potential implications that may have had thus far for seafood products coming out either open ocean aquaculture or for wild catch. Has there been any research looking at potential residues of contaminants in products from those areas? And a related question is, what do you see as the regulatory role in terms of protecting consumers from chemical contaminants in seafood?
So it was April 11th, 2010, that rig blew up. I was actually on a plane from Tampa, so I was actually flying over it when it blew up on my way to New Orleans. I didn't see it. It would have been a cool photo in some ways. But so from the moment that happened and they sort of understood the extent of the plume, they closed fully a third of the Gulf of Mexico to all fishing, period, end of story. So during the 66 days, there was a complete closure of a third of the Gulf of Mexico, and they did sort of rigorous water quality and sediment and seafood testing before they opened sections back up, sort of honing in on the epicenter where the explosion happened, so because the distant areas had less contamination until you got a fully open Gulf of Mexico somewhere, I think it was in October. So that was the sort of ultimate application of the precautionary approach right there, is just to say we're not going to let anybody do anything here. And the tests they did on finfish species like red snapper, grouper, those are very popular products that end up in the marketplace, is that the things like oil are metabolized fully by the organs, and so it never reaches the muscle tissue, which is what you consume. And then in 2 days, 48 hours, that fish is fully metabolized hydrocarbons, which is phenomenal, right? Like, that's a pretty impressive turnaround for having a fish. Sort of, I have exorcised the demons, if any of you are old enough to remember that movie. So that was great news for the seafood and for the fish health and all of that. The shellfish, of course, are filter feeders, are not as lucky, and so there are areas in Louisiana that are still not open to fishing these many years later because the oil really damaged sort of the benthic sediments where those things live, and it's just not safe for people to even think about growing food there. But one of the sort of nagging, persistent, yet unknown impacts has been, we saw this proliferation of diseased red snapper in the northern Gulf of Mexico, which of course is where most of the oil made it to shore. And they would show up with these sort of really horrifying, like junior year of high school health class video, horrifying lesions on their sides. And nobody could really understand if those were always present, but people were just more diligent about reporting them because they thought it was an oil impact, or if the oil was actually having impact on these fish. And so they did, a number of different universities collaborated on some studies, and they realized that, one, it is a naturally occurring bacteria that's causing this, and two, it is occurring much more frequently than it did before 2010. So there's no actual toxicological damage to the fish, like flesh, right? So if these things went to market, you would think, ew, gross, I'm not buying that, but it wouldn't actually kill you, in theory. I have not sort of personally tested this. But when they cut the fish open and examined their internal organs, a 10-year-old fish would have the liver of a 45-year-old fish. And so the process of sort of getting rid of all these chemicals in that fish's system through the liver and through the sort of endocrine, the whole system, was really stressful for them. And it aged their liver like dramatically, which I thought was very interesting. And it made the fish more vulnerable to naturally occurring diseases and parasites. And so that's not a smoking gun, right, of, sort of BP broke our red snapper fishery, but that's sort of a connection that people are trying to sort of understand. And that happens on a fish that we regularly encounter in the Gulf because we like to fish for it, we like to eat it, and we like to sell it to tourists. So it begs the question, what's happening to fish that we don't encounter a lot? Because the encounter rates are still quite low of seeing these lesions on red snapper, or something that comes, there's a 11 million pound catch limit, so we see 11 million pounds of red snapper annually. What about something that we don't fish for? Those could be completely damaged, and we just don't know because we don't see it. And so there are hints and there are indications that this is an ecosystem that has some trouble, but the Gulf itself has naturally occurring oil that the ecosystem has just learned, oil seeps and things, to sort of absorb. So where's that tipping point between, you can absorb this much before your ecosystem has an effect? We don't know any of that. So there could be, there are impacts out there that we don't know about yet. It's just a matter of when they show up and if they cause health issues. That's sort of pressing. And after all that, I forgot your second question.
It was about a regulatory role for protecting consumers from potential contaminants in seafood. And so, related to some of the points you made, how might those concerns be different for other aquatic animals that we eat the entire thing, like a shrimp, we're eating the entire organ system. So do those concerns differ for mussel versus other organisms, or eat all organ tissues?
Yeah, it's certainly compelling to hear the sort of story of that bacteria and what it did to the red snapper, or how metabolizing oil made the red snapper susceptible to that bacteria, sort of telling for something like a shrimp where you'd eat the whole thing. And seafood testing, we test a pretty small percentage of what goes to market. We test a pretty small percentage of what we import. And so I actually, in the spirit of full disclosure, find it remarkable more people don't get sick from seafood because we test a little of it, and sometimes we find issues and sometimes we don't. So, that to me is not that we need better testing protocols. There's just a funding deficit, right? It's expensive stuff to do petrochemical sort of testing on finfish, and they found money for it certainly during 2010 to do a whole lot of it, but and I'm sure the sequester sort of snipped plenty of that off. So it just, there's an answer out there, right? That, you can do things better, faster, more efficiently, better use of technology. It's just a matter of creating demand for those innovations. And right now there's not. So my big wrap up would be an excellent role for public health in helping us create the demand for better systems. In a way that sort of conservation and advocacy can't do on its own. Well, you asked some great questions. I'm gonna turn the party back over to Jillian here.
Oh, sure. Did you have another story?
Oh, I did have another story. That's right. It's not as good as the hockey one, though. I should always end with the hockey one. So I worked in the Caribbean and the Turks and Caicos Islands for a year after I graduated college. And I took just like a casual vacation. I just flew over to Grand Turk from the island I was on, South Caicos. And I didn't know anybody there, and I didn't really know where I was going. I had some dive gear, and I was going to go scuba diving or whatever. And I hear this sort of yell from the bushes, "Hey, you!" And now that I'm 35 and live in a city, this sort of "Hey, you" does not get a response from me. But at 22 and in Caribbean paradise, I was like, "Sure, what do you need?" And the guy was like, "Hey, I saw you on the plane. You want to come have dinner with my friends and I?" And so there's just a bunch of guys sitting on a bunch of stumps under a tree with like a bonfire and then beers. And so what 22-year-old is going to be like, "No, this doesn't look like any fun. I'm going to go try to find some other fun because I'm here by myself." So sure, of course, I take their invitation. I go sit down, have some beers, and they're like, "Oh, we're gonna cook some fish. Are you interested?" And I was like, "Sure. What do you got?" And they were like, "Oh, don't worry about it." And I was like, "All right, sure, whatever." So after. It's not important how many more beers and merriment, with the bonfire and the eating of fish and snacks and whatever. One of the guys and the fisherman comes up to me and he's like, "Ha ha ha, that was barracuda, ha ha ha." And I was like, why is that funny? Well, it turns out that they have a huge issue with ciguatera and barracuda in this particular area, and no one in their right mind would eat a barracuda that time of year in the Turks and Caicos Islands because they know that algae is sort of nearby and the barracuda are really susceptible to ciguatera. And so they all thought it was hilarious that they almost made me kill myself. I mean, they all ate the fish as well because they knew where they caught it. And they knew that those waters were really clean, but I had no idea what I was doing. And so my plea to you from all 22-year-olds everywhere is to save us from ourselves, right? And information is power. If you know how to make better choices, maybe you can sort of save yourself from imminent death. So thank you all for sticking with me and even leaving me some lunch over there. I really appreciate the opportunity to be here.
That was excellent. Thank you, everyone, for coming, and I hope we see you next month for the film screening and the discussion.